Hello students, today's discussion is about the main properties of D block elements. You know that group 3 to 12 in the modern periodic table is belonging to D block and it mainly consists of metallic substances. All the transition metals are mainly metallic in nature. That means they show the property called malleability, ductility, shiny appearance, sonorous nature, and they are good conductors of heat and electricity. In addition to that, the most important point shown by D block elements is that they can show variable oxidation states. If you check the 3D series, you find that a variety of oxidation states are shown by these elements. The starting element scandium shows only one oxidation state plus 3. Titanium can show a variety of oxidation states starting from plus 2 to plus 4. Vanadium can show plus 2 to plus 5. Chromium will show a variety of oxidation states starting from plus 2 to plus 6. Manganese is showing the highest number of oxidation states plus 2 to plus 7. Same is the case with iron. Here you find that it shows plus 2 to plus 6 except for plus 5. Cobalt can show plus 2 to plus 4. Nickel can show plus 2 to plus 4. And copper is showing plus 1 and plus 2. And zinc is showing only plus 2 oxidation state. All this happens because the d electrons are also involved in bond formation. Since the d orbitals are also involved in bond formation, it is also readily available for donation. This is the reason why the D block elements show a variety of oxidation state. When we analyze the different series, you find that the middle element in the series will show maximum oxidation states because they are having maximum number of unpaired D electrons. On checking the D block elements, you find that most of them exist in the solid form, mainly in hexagonal close packing with a BCC arrangement, that is body centered cubical arrangement, and in some cases it even exists as cubical close packing. Now you find that some of the elements which are included under D block, they are considered as pseudo transition elements. What do you understand by pseudo transition elements? You find that these elements have completed d orbitals in it. And which are the different pseudo transition elements? The elements that come in the 12th group, that is zinc, cadmium, mercury and copernicium. They have completed d orbitals and so their d electrons are not available for bond formation. So these elements, even though they are included under d block, they are not showing all the properties of d block elements. So they are considered as pseudo transition elements. Other cases, you find that the d electrons are also involved in bond formation and so they are considered to be transition elements. Coming to the next property, that is melting points and boiling points of transition metals are generally high. Have a closer look at the graph given here. This represents the graph against the atomic number against melting point. So here you find that the 3D series starts from scandium. You find that it is showing a maximum melting point at chromium and then there is a dip in the curve at manganese and then you find that the value keeps on decreasing. Same is the case with 4D series. You find that maximum value is seen for molybdenum, then a dip is shown in technetium followed by ruthenium and the value keeps on decreasing. On analyzing the 5D series, you find that lanthanum, hafnium up to tungsten, you find that the value keeps on increasing and from tungsten onwards, the value keeps on decreasing. All this happens due to the fact that the melting point is related to the number of unpaired electrons. More the number of unpaired electrons, more will be the metal bonding, and so more energy is required for breaking the bonds. And due to this reason, the enthalpy of atomization of these elements are found to be high. So except for manganese and technetium, you find the middle elements which are having maximum number of unpaired electrons are having maximum value for melting and boiling points. Now we are going to have a look at what happens to the atomic radii when we move in the different series. So on analyzing the graph here, you find that the three different series are given here: 3D series, 4D series and 5D series. So you find that the atomic sizes are keeping on decreasing here, and you find that, and later on you find towards the middle it is almost the same, and towards the end it is slightly increasing. And this happens due to two factors. You can just recollect what was taught in the earlier classes. You find that the atomic sizes are related to two factors. One is the effective nuclear charge and the other one screening effect. When effective nuclear charge is more than the screening effect, you find the size keeps on decreasing, whereas when it is equal, it will be almost having the same sizes. And when the screening effect overpowers the effective nuclear charge, the size keeps on increasing. Hope it is clear. Coming to the next property, that is catalytic property. You find that D block elements mainly act as catalyst, either in the elemental form or in the compound form. I am taking the example of iodides reacting with persulfate ions. If it is analyzed, you find the product form will be iodine and sulfate ions. This happens in the presence of Fe3+. Now, why that Fe3+ acts as a catalyst here? What happens here is, because of the variable oxidation state exhibited by iron, it can act as a very good catalyst. So first of all, what happens is Fe3+ will combine with iodide, converting it into Fe2+ and iodine. So here you find that on balancing, you find that this will have 2 iodide, Fe, Fe. Now the charge has to be balanced, so I give 2 Fe3+ here. So 2 Fe2+ is given, so total charge will be +6 and -2, so that will be +4. Here also it is +4. So this is the balanced equation. Now subsequently what happens is Fe2+ that is produced will combine with S2O8 2-, and here it again undergoes Fe3+, so that is oxidation occurs, whereas persulfate ions will be converted to SO4 2-. So this is 2 times. So we'll just check the balanced equation here. Fe2+, Fe3+, S2, S2, O8, O8. What is the charge here? It is charge is +2 and -2 here, so you have to give it as 2+, 2 Fe3+. So then the net effect will be Fe3+ will be cancelled out, and we get 2I- giving I2+ 2 S2O4 2. minus. Iodides combine with persulfate ions to convert it into iodine and sulfate ions in the presence of Fe3+. Why this happens is because Fe3+ can be converted to Fe2+, Fe2+ again on subsequent reaction it will be converted to Fe3+. So it will get cancelled out. So if find the reaction is happening in the presence of Fe3+ without itself converting into the product. Another important property of D block elements is that they are involved in formation of interstitial compounds. What do you understand by interstitial compounds? Here you find we have learned that D block elements exist either in HCP arrangement or CCP arrangement. It can be body-centered cubical structure or cubical close packing. So here if I draw the metallic atoms like this, so this will be the lattice structure of the D block elements. Suppose you check the voids here, you find that there are many gaps in between. So these gaps, when it traps small atoms like hydrogen, carbon, nitrogen, etc., they will bind together without any direct bond formation. Still the compounds are formed, and such compounds that are formed when small atoms like hydrogen, carbon, nitrogen, etc. get trapped in between the voids of the metallic lattice, that is known as interstitial compounds. These interstitial compounds, they are found to be inert in nature and they have high melting and boiling points, and you find that they are very tough in nature. So you find that interstitial compounds are of industrial importance. D block elements are also involved in alloy formation. Now what do you mean by alloys? Alloys are solid solutions of metals. Now what do you understand by solid solution of metals? So the metals which are having similar sizes, when they get mixed with each other, the mixing should be such that one is melted and the other one is mixed in that, and you find that the value should be around 15% of the first one, and you find that the compounds that are formed, they are called alloys, which are lightweight and they are very tough in nature. They have high melting and boiling points compared to the pure metals, and they are corrosion resistant. The most important example for alloys that we have, that is known as brass and bronze. Components of brass are zinc and copper, whereas bronze will have copper and tin as its constituents. D block elements are also found to form complexes or coordination compounds. Here you find that small atoms which are either neutral or charged will coordinate with the metal atom, which is a D block element. So here the ligands like ammonia or chlorine get attached here to atom through coordinate bonds. And why this is possible here? Because of the small size of the metal atom, the availability of high charge and availability of vacant d orbitals that the d block elements are able to form complexes. So it can be neutral complexes or charge complexes as the case may be. Hope you have understood all the main properties of d block. Thank you.